Alright, for number 16, we have 25x minus 2 is equal to 125 to the 4x. We got to have the same basis. So we can rewrite this as 5 squared. And we can write this as 5 cubed. Because what we've done here is replace the bases here and rewrote them in terms of 5. Okay, now that they have the same base, we can just put the exponents equal to each other. So we'd have 2x minus 4. I'm going to go ahead and distribute this. Is equal to 3 times 4. So I'm going to end up with 12x. But again, once you've got the same bases, you can just put the exponents equal to each other. Alright, so I'm going to subtract 2x from both sides. So I end up with negative 4 is equal to 10x. Divide both sides by 10. So we get negative 4 over 10. Now we're going to reduce this. This will reduce to negative 2/5. And if you wanted to, you could check by placing it in and seeing what you come up with. Alright, number 17. We have another exponent equation to solve for. Here we have 4 to the 5, 2 plus x is equal to 1024. Alright, now you may have to try this. Now, just by looking at it, I would try and base of 4. I would see what the multiples of 4 give us. If that didn't work, then I would go down to 2. But luckily for this one, 4 works. So 4 to the 5th power gives us the 1024. Okay, so now we have the same basis, so we put them equal to each other. So I'm going to end up with, I'm going to go ahead and distribute so that I end up with 10 plus 5x is equal to 5. Okay, subtract 10 from both sides. So I get 5x is equal to negative 5. Divide both sides by 5. And we get x is equal to negative 1. Alright, for problem 18, we have 4x plus 1 is equal to 32 to the 2x. Now the temptation, try 4, it's not going to work. So we're going to have to write this in multiples of 2. So 2 squared gives us 4. And 2 to the 5th power gives us 32. Alright, so what I'm going to do here is distribute this through so that I get 2x plus 2 is equal to 10x. Alright, subtract 2x from both sides. And we get 8x is equal to 2. Divide both sides by 8. And so we have 2 over 8 is equal to x. We're going to reduce this to a 4th. And that's our final answer. Alright. Alright, number 19, similar process. It's just we have an inequality. Still have to have the same base. Now I would try 9, but 9 squared gets you 81, so that doesn't help. So 3 will be the one that works for us. So 3 squared gives us 9. 3 to the 3rd power gives us 27. So we'll end up with 2x is less than or equal to, go ahead and distribute the 3 here, 6x minus 3. Okay, I'm going to subtract 6x from both sides. So I get negative 4x is less than or equal to negative 3. Okay, we're going to divide both sides by negative 4. Now when we cross that inequality with a negative, we got to reverse it. So it'll be x is greater than or equal to 3/4. Alright, similar type problem. We're going to write 9 in terms of 3. So our base here is 4x, meaning 3 to the 4x plus 2 is greater than or equal to 3 squared. We'll replace 9 with 3 squared. Okay, there's nothing to distribute here, so I'm going to have 4x plus 2. Now they have the same base, so I can just use the inequality here. And I'm not getting rid of the bases, but what's happening here is once I have the same base, the exponents have to be equal. Alright, so now I'm going to move 4x over. I'm subtracting, not multiplying or dividing with a negative, so I don't have to worry about reversing the inequality. But anyway, I subtract here, and I get negative 2x. Divide both sides by negative 2. Okay, now when I do that, I'm dividing now, so now I do have to reverse the inequality. I end up with negative 1 and x. Now, this answer is fine. Now, just in case on the multiple choice test, your variable ends up being on the left. If I was switching this around to make sure it matches up, what I would do is put x and then make sure it's still pointing at the negative 1. Okay, and then those mean the same two things. These things, so if you have either one of those answers, it means the same, and that's correct. Alright, for question 21, it's a population question. Alright, so when you have exponential equations, typically you're going to end up with something like this, plus or minus, it depends, and some type of time or some type of variable here. Well, in this case, we're talking about population. So we started out with 12,800. Okay, now it's an increase. Now when we increase, we're going to add. Now, so we're going to add the 0.03. Now remember, when we're taking 3%, we're converting it to a decimal, so that's why it's 0.03. And then it's a function of years, and they told us to use n, so we'll put n as our variable. So we're just setting up the equation in this case. So we end up with 1.03 to the n. Now, just as a word of note, this number right here has to be greater than 1 for it to be an increase. So for it to be a growth, this has to be bigger than 1. For a decay, if something was decreasing, this would have to be less than 1. Okay, so that's our function. That would be part A. Now for part B, okay, they want to say, well, what happens after 15 years? So we take this and we're just going to plug in 15 for the n. Alright, so we should end up with this. Now we're talking about people, so I just rounded to a whole number. Alright, and so that's what our population should be close to for 21. Alright, so for number 22 we have a depreciation. So similar type process, except we're going to subtract the rate that it's decreasing here, and then they tell us that our variable is t this time for years. So let's look. So it started out worth $20,000. Okay, and it's decreasing 12%. So that's going to be 0.12 over the life of however long you have the boat. Alright, and so we would just take the difference here, and so it'd be 20,000 times our decay factor of 0.88 to the t. Now remember, we're decaying, so it has, or decreasing, so this has to be less than 1. Okay, and so this is how we would set up the equation. So that would be the A part. Alright, now B, it says graph it. Now, we can jot our graph without too much trouble with this. You don't have to be too elaborate with this. Alright, so if I'm jotting a graph down, okay, I know it's a decay. And so I can pick one point. If I put in 0 here, it's going to be 20,000. So we're going to do a rough graph. So at $20,000, when at year 1 we're at $20,000, and then it's going to constantly get smaller and smaller from there. So I'm going to just say that's $20,000 at year 0, and then at year 1 it's going to decrease some, and it's going to keep coming down until we get to some point over here. So I know we're going to end up something like this, and we're never going to owe more, so it's going to get closer and closer to 0 at some point. So that's a rough idea what the graph should look like, because anytime you have a decay, it's just going to come down. Alright, now what's the domain? Domain's all real numbers. You can put any number you want to in there for the domain. As we talk about this, we say all real, but let's talk about it. It's talking about time. So we're starting at 0 and we're going. So we really couldn't be less. You can't have a negative year. So we say all real numbers. But what we're really talking about is from 0 to infinity, because time. We're talking about time. So it could be 0 years. So really we are limited here. We wouldn't say all real for this case because you can't have a negative year. Alright, and then D, the range. Okay, the lowest value you can have is what? 0. So the range Y has got to be greater than 0 if you want to keep the same pattern. But it also can't be more than $20,000. So we're going to say the range is from $0 to $20,000 because we're talking about money here, because it's not going to cost us more than $20,000. So the range is from $0 to $20,000 because that's the highest value. Alright, now the asymptote, we won't ever cross 0, so our asymptote is 0. So Y equals 0 would be the asymptote. Alright, then finally, the last question, F, says after how many years will the boat have a value of about 4,900? What I would do is just put 4,900 here and put it in for this. Okay, now we can either start plugging in values to figure out what it is, which would probably be the best bet. So if I plug in numbers for this, if I put in 10 years, the boat is worth 55,700. I mean 70. So it's 5,570. Okay. So if I put in 10 for T, I should get this. Now if I put in 11 for that, I get 4,901. Which the question asked, when is it going to be less than, or is it say less than or around then? Of about. So it says about. So they want to know when it's around this number. It doesn't say less than. So we would come up with 11 years. So it's just kind of plug and chug until you get a value that's close to that. And so 11 years.